computers have come a long, long way since Charles Babbage developed plans for the first computer prototype back in the 19th century. Today, they're an inescapable part of modern life. But what if we were due for yet another computing revolution in the coming decades? IBM recently unveiled a groundbreaking machine, the IBM Quantum One, the very first integrated quantum computing system available for commercial use. It's unlike any other supercomputer in the world. Quantum computers could make it possible to compute orders of magnitude faster because they can consider large numbers of possible situations simultaneously. For example, when trying to find the fastest and most energy-efficient route between two locations. So what makes computers like IBM so different from a regular supercomputer exactly? The answer is in its name. The IBM Quantum One is a quantum computer. It represents the evolution of classical or binary computing, upon which the foundations of the modern world are built. In classical computing, data is encoded in binary bits, the ones and zeros we're familiar with. At the most basic level, this data gets sent out to a computer as instructions. The computing power of a processing unit for a classical computer, such as a graphics card or CPU, is most often determined by how many transistors are on board. Like a light switch on the wall, the transistor either prevents or allows current to flow through. It can either be on, 1, or off, 0, at any given time. For reference, the Ryzen 9 5950X, one of the most powerful CPUs you can get for a personal computer nowadays, has about 10 billion on board. Quantum computers, on the other hand, are a completely different beast. Here, data is encoded in quantum bits, or qubits. This means that data isn't just encoded in either ones or zeros, but also both at the same time. So how does this work? This is due to the nature of quantum computers. As suggested by their name, quantum computers operate at the subatomic or quantum level instead of on and off. The physical systems that make up qubits use the state of quantum particles, such as the spin of an electron or the orientation of a photon. Thus, qubits can exist in many states at once, a property known as quantum superposition. They can also be linked together in a phenomenon known as quantum entanglement, which allows data to be represented as both a 1 and 0 at the same time. Due to this additional processing power, a quantum computer featuring enough qubits could have more computational states than there are atoms in the known universe. However, the unique way in which quantum computers work also calls for unique operating conditions, namely their cooling systems. While air or water cooling work great for regular computers, quantum computers need quite a bit more to operate at maximum efficiency. Due to the volatile nature of the particles that make up the qubits that power these machines, they're incredibly sensitive to the slightest vibration or fluctuation in temperature or electromagnetic environment, losing their fleeting quantum properties within microseconds. As such, most quantum computers need to be kept in a sealed, cushioned environment and operate at temperatures close to absolute zero to minimize environmental interference. That's about minus 459.67 degrees Fahrenheit. These operational requirements, their incompatibility with day-to-day computing tasks, and the millions of dollars it would cost to acquire one of these for personal use, mean we won't be seeing quantum computers in our living rooms anytime soon. Some scientists even speculate that 100 years into the future, we'll still be relying on classical computers to get us through our day-to-day tasks. But that doesn't mean we won't be able to utilize the power of these fantastic machines. Today, there are several commercially available quantum computers in the cloud. Aside from IBM and their Quantum One, Google also offers cloud-based usage of IonQ's quantum computers on the Google Cloud Marketplace. Researchers, companies, and developers can gain access to this revolutionary technology to perform incredibly complex computations, making previously unfeasible research projects possible. which could be used to speed up advances in the healthcare, energy production, machine learning, and artificial intelligence industries. With a quantum computer, industries across the world will be better able to solve complex problems our current technology can struggle with. More accurate and precise weather predictions will become widely available. Algorithmic stock trading may become possible. Logistics and supply chain management could see massive efficiency gains. The possibilities are endless.